In the previous lecture, we talked about double integrals and solved some examples. Here, in this example, we have given two double integrations. We are asked to rewrite the iterative integral with the order of integration reversed. That means here it's given, for example, in the first one, it's given that it's dy dx. That means you should check the first integration with y and then with x. It's impossible to find that integration in this way. So what we do, we're going to revise the order of the integration. That means we reverse the order of the integration. As dy by dx, we change to dx dy. We solve that example. Okay? By changing the order of the integration, these lower and upper limits are going to be changed. These are going to be changed also. Okay. Here we have the second example. We solved the first one in the last lecture. We now have the second one. In the second one, we have the double integration of x e to the power 2y divided by 4 minus y, where y is from 0 to 4 minus x squared. This is for the first integration. That's dy. And x is from 0 to 2. We are going to find this integration by reversing the order of the integration. Let's write down the integration first. We have the second part. We have the double integration from 0 to 2 and from 0 to square root of to 4 minus x squared. These are the limits of the integration, and the function is x e to the power 2y dividing by 4 minus y dy dx. 4 minus y dy dx. Okay. What we do here we cannot find this integration because here we have in this order. So the first integration with respect to y, we cannot find the integration with respect to y here. What we do, we are going to reverse the order of the integration. It's dy dx. We are going to change to dx dy. And even we are asked to reverse the order of the integration. We are going to change to dx dy, then we find it. It's important to draw a graph of the lower and upper limits of the integrations. We have two integrations. Each has lower and upper integration. Let's first draw the graph of these two functions and these two functions also. We have xy plane. This is x and that's y. Now, for x is from 0 to 2. That means x equals 0 and x equals 2. From these two, we are going to draw their graphs. X equals 0. That means it's the vertical axis. Yeah. This is x equals 0. Okay. And x equals 2 at x equals 2, we have a vertical line. The graph of x equals 2 is this one. Okay, this is x equals 0 and this is x equals 2. And now we have functions of y equals 0 and also y equals 4 minus x squared. Y equals 0 is the horizontal axis. Let me use another color for that. Y equals 0 is this one. is the horizontal axis, and y equals 4 minus x squared. 4 minus x squared. And this is the graph of x squared. And 4 minus x squared, this graph shifts 4 units to up. This graph shifts 4 units to up. So it becomes 1, 2, 3, 4, and gets here. But be careful, the graph intersects x-axis at 2. The graph intersects x-axis at 2. Okay. This is the graph. So the region which is bounded by these two vertical lines and the horizontal line, which this is y equals 0, and this is y equals 4 minus x squared. The region which is bounded by these four is. Because here at 2 y is 0. As you see, at 2 y is 0. That means at 2 it intersects for x-axis, and even at -2 it intersects x-axis. Because here, if x to be 2 or x to be -2, y equals 0. That's why it intersects x-axis. But this is the intersection of the graph with x-axis. Okay. Now the region which is bounded by these four lines is this one. As you see here, it's bound by those two red lines, and y equals 0 and the graph. That region is bounded by those four functions. This is our region. We are going to find area of that region. Okay. Here, what we do to reverse order of the integration, we are going to go through the graph horizontally for x, vertically for y, horizontally for x and vertically for y. As you see, this is 4. This is 4. That means the graph vertically goes from 0 to 4, from 0 to 4. Okay, and horizontally is going from 0 to that graph, to this one. If you go through the graph, through the region in this direction, where do you enter to the graph? To the region at x to be 0. And when do we leave? When do we leave the region? At this curve. So what's the function for this curve? The function for that curve is y equals 4 minus x squared. But here we must write down for x. So x is square root of 4 minus y. A square root of 4 minus y. From this function, we can get that x is 4 minus y in a square root. Is it? Yeah, we have y equals 4 minus x squared, moving this to here and this to there, we get x squared equals 4 minus y. And x is square root of 4 minus y. That's it. So now, we say horizontally, we go through the region from x to be 0 to where? To x to be 4 minus y. That means x equals 0 to x equals square root of 4 minus y. These are the lower and upper limits for the integration with respect to x. And then with respect to y, we go vertically through the graph. If you go through the graph vertically, let's see this. If you go through the graph in this direction, where do you enter to the graph? We enter the graph at this line. And at this line, what's the value of y? It's 0, because it's horizontal axis. At that line, y is 0. And then when do we leave the graph? At this line. Okay? At that line. And at that line, what's the value of y? is 4. لأن بونا على function كود درس من y. بوشي function كم دانا بو x. لبرو ordinary integration كأجورين كorder كأجورين أبيت أنها كم دانيان بfunction بيت. يوم دانيان أبي بvalue بيت. باشا. So these are the lower and upper limits for the integration. These are the lower and upper limits for the integration. If we have dx dy, that means the double integration becomes, we have dx dy. The function is the same, x e to 2y dividing by 4 minus y. So what are the lower and upper limits for x? It's from 0 to square root of 4 minus y. We don't say it is 4 minus y to 0. Because if you go through the graph through the region from left to right, we first enter to the region at x to be 0, and we leave the region at that function. Then for y is from 0 to 4, because if you go through the region vertically, we first enter the region at y to be 0, and we leave the region at y to be 4. So from 0 to 4. As you see, the limits are changed. It was from 0 to 4 minus x squared, and the second one is from 0 to 2. But now, it's from 0 to square root of 4 minus y, and then from 0 to 4. We have these 4 upper and lower limits. So now, what we do, we are going to find the integration. The integration of this function with respect to x is what? What's the integration of this function with respect to x? E to the power y over y, 4 minus y, that's constant. We just have x. We just have x. So the integration of x is x squared over 2. You say it equals integration from 0 to 4. We still have this integration. We first take this integration, and the second integration is for y. The integration of this function is e to the power y over 4 minus y times x becomes x squared over 2. That's all. Now we put lower and upper limits, 0 to the square root of 4 minus y. What do we substitute by these two values? We substitute x by these two values because we took the integration with respect to x. We don't substitute y by these values. We substitute x by these values, by these lower and upper limits, because we took the integration with respect to x. So it equals the integration from 0 to 4, e to the power y over 4 minus y, x squared over 2. We first replace x by square root of 4 minus y. We get 4 minus y in a squared over 2. These are cancelled out, and you get only 4 minus y. Is it? I'm just going to write down 4 minus y. 4 minus y over 2. Then minus. We replace x by 0. We first put the upper limit, then minus, we substitute the lower limit. Minus 0. Then dy. These are cancelled out. We get, yeah, it equals the integration from 0 to 4. e2y, sorry, that's 2y. I forgot to write down this 2. Yes. Over 2 dy. Now we take the integration with respect to y. e2y with respect to y, if we take its integration, it becomes 1/4. Here we have a half. And another half is 1/4. E to the power 2y from 0 to 4. It equals what? We first replace y by 4, then we replace by 0. 1/4 e to the power 8 minus 1/4, because if you replace y by 0, you get 1/4. So it equals 1/4 e to the power 8 minus 1. This is the result. So that's the result for that integration. We took 1/4 as the common. So this is the result for that integration. Okay. Even if you cannot find the integration, you can reverse the order of the integration to find its integration. Okay. Here, for this integration, can you find x e to the power 2y over 4 minus y dy? Can you find this? It's impossible to find this integration. It's difficult to find it. So here, it's easier. It's easier to change the order. I mean, these are functions. It's easier to reverse the order of the integration and then find its integration. But here you have x only. It's easy to find integration with respect to x because you have only x, that's x squared over 2, and the rest are constants. So that's why we use changing of order for the integration, then we find the integration. That's all. And here, in changing the order, it's important to draw the region. You should draw the region first and then do it. This is the region. Find the region is bounded by the lower and upper limits. And then go horizontally through the graph for x and go vertically to the graph for y. Do you have any question about that? We now have double integrals in polar coordinates. In polar coordinates, we should know these formulas. It's the relation between Cartesian and polar coordinates. We say x is r cosine theta, y is r sine theta, y is r sine theta. How? In this triangle, this is x, this is y, and this is r. And this angle is theta. So here we say sine theta equals to what? Equals opposite dividing by the adjacent, but y dividing by r. Okay, and cosine theta equals to what? X dividing by r. Okay, so from this we can get that y is r sine theta, and from this we get that x is r cosine theta, and then r squared equals to what? R squared equals x squared plus y squared. If you find the square of these two, let's do. The square for this one is x squared equal. Let's find x squared plus y squared. X squared plus y squared equals r squared cosine theta squared plus r squared sine theta squared. That equals to, let's take r squared as the common. We get cosine square theta plus sine square theta. That equals to r squared times 1. Cosine squared plus cosine squared is 1 by triangle identities. And this, so you get that x squared plus y squared equals r squared. X squared plus y squared equals r squared. That's it. Here we have x squared plus r squared, y squared is r squared. And tan theta equals y over x. As you see, tan this angle is y over x. So that's it. Here we have these formula. X is r cosine theta, y is r sine theta. For converting a function to polar form, we replace x by r cosine theta. We replace y by r sine theta. and replace x squared plus y squared by r squared. Okay, and also y over x by tan theta. We should convert the function from xy to r and theta. We should convert the function from xy to r and theta. Here you see the double integration for f of r theta dA is over the region. The double integration for that function over the region is this limit. Here we don't use this summation in finding the double integration. We don't use it because this difficult for you. Here we apply this one as for the summation. We don't use that. We use Frobenius theorem for finding the double integrations. You don't need to use or memorize this. Okay. First, before I talk about this is the Frobenius theorem. We use Frobenius theorem for finding double integrations in polar form. We don't use this rule. Before I talk about Frobenius theorem, you should know how to draw the graphs in polar coordinates. What's the graph of sine x in polar coordinates? We say sine x, sine theta. Sine theta. To draw the graph of sine theta or sine x, it equals to what? Equals to a circle which that's it. This is the graph. This is one. So the highest value that sine gets is 1. It is the graph of sine theta. This is the graph of sine theta. Look, here we count the angles like this. These are the angles. Okay. And then to draw the graph of cosine. So it's the cosine function here. For cosine theta, as this one. We say it is a circle on the x-axis. For cosine, we use x-axis, and for sine, we use y-axis. Okay. Here, this is 1. That means the highest value of cosine is 1. The highest value of cosine is 1. So what's the angle here? It's from 0 to pi. As you see, this circle is starting from angle 0 to pi. For sine, it's starting from 0 to pi. It's not exceed pi. So here we say the angle here is from 0 to pi. Theta belongs to this. How about for cosine? What's the angle belongs to? Theta belongs to what? From minus pi over 2 to pi over 2. Okay? It's starting from here to where? To here. As you see, let me draw it again. We start from this angle to this angle. Okay? As you see, it's not exceed pi over 2, and it's not exceed minus pi over 2. That means the angle belongs to minus pi over 2 to pi over 2. Sorry, pi over 2. This is the angle here. So how about 2 sine theta? How about this one? It's the same as sine, but from 0 to 2. Yeah. This from 0 to 2. This is 2. Okay. That's 2. That's all. Okay. So how about 3 cosine theta? 3 cosine theta. Yes. What else from this is 3. It goes from 0 to 3. Yes. Yes, the angle is from minus pi over 2 pi over 2. Yeah, it's not changed. Yeah. So how about R? If R to be, let's say, 2. How about this one? If R to be 2, that means x squared plus y squared equals R squared, which is 4. That means we have a circle with center as 0, 0, and the radius is 2. Okay, when you say R is 1, that means we have a circle with radius 1. When you say R equals 2, it means we have a circle center as 0, 0, and this is 2. Okay, so if R to be, let's say, 1, how about this one? It's the same. From 1, okay, the radius is 1. Yes, minus 2. Okay, that's it. That's for R, and that's for sine and cosine. So if you have, let's say, 1 minus or plus 2 cosine. How about this one? If you have 1 plus cosine, let's do it. How about 1 plus, let's say, sine theta? Look, no. Look at this. Here, at pi over 2, the sine function is 0. Is minus pi. At negative pi over 2 at this angle. So at here is 0. Is it? So how about at this? Yes. How about at 0? This is theta is 0. It's pi over 2. This is pi. This is minus pi over 2. At pi over 2, it is 0. Okay. At 0, the value of this function is what? It's 1. At pi, it's still 1 because sine pi is 0. So it's 1. How about at pi over 2? At pi over 2, this becomes 1. 1 plus 1 is 2. Is it? Now we join these. How it goes? It goes like this. This is the graph. Okay? This is the graph of sine 1 plus sine theta. So how about the graph of let's say 1 plus cosine theta? Let me do it beneath here. In minus pi over 2, we get negative 1 here. That's why it returns to 0. How about 1 plus cosine theta? How about 1 plus cosine theta? Look, at 0, we get 1 here. 1 plus 1 is 2. So it's 2. Okay. At minus pi over 2, this is 0. 0 plus 1 is 1. Is 1. At okay. 0, 2. How about pi? At pi, what we get? At pi, here we get minus 1. Okay, it's 0. Yeah. How about pi over 2? It's still 1. So the graph is like this. Okay, this is the graph of that function. كامل بوشو look ليرة شلون بسمو بوم خالة اگر قوشي ول بقرم ليرة سطو بيس ول بقرم كوساين صو بيسوني بالي اكاتا رقي سيلة سردو وايا رقي سيلة سردو إياك زائد رقي سيلة سردو ناقص رقي سيلة سردو 1 minus square root of 3 over 2. It's a point somewhere here. Okay, that's why we go like this in a curve. For minus pi over 2, it's 1. Yeah, it's cosine is 0, but you get 1. That's the graph. Again, minus or green, below. I did it. For minus pi over 2, it's 1. That's in the above. It's not minus 1. Okay? Look here, take an angle between pi over 2 and pi. Yeah. Yes, it's the same. You don't need to take that angle, but راسان بسیاری کرد بویا وتی چون بزنی آپیت ایو کرف لوگینی. Okay. So now we talk about the regions which is bound by 2 of these graphs. Okay. So what's the region which is bounded by r equals 1 and sine theta? R equals sine theta. How about this? So what's the region which is bounded by these two functions? For r to be 1, you have a circle with the radius at 1. Okay? That's it. And let's say it's 2. And how about r equals 2 sine theta? How about this one? It's a curve or it's a circle. Yeah. Like this. This is 2 and this is 1. So what's the region which is bounded by these two graphs? The region here which is bounded by these two graphs is this one. Okay. At starting from 0, that's angle 0 to where? To pi. And r is going from 0 to 1. R, this is r and this theta. Theta is going around this. Okay. And r is going from 0 to where? To here, to here, to here, to here, to every point on the region. To there, to there, to there, to there. So what's the highest value? The highest value is 1. So r is 0, r is 1. And theta is 0, theta is pi. These are the lower and upper limits of the integration that you will find. Now, let's take another example. If we take 2 more graphs, if we say we have r, let's say to be 1, and r to be 1 plus sine theta. So what's the region which is bounded by these two graphs, these two functions? For the first one, we have r equals 1. R equals 1. That means we have a circle which is as 0 and its radius is 1. This is 1. This is 2. Now, r to be 1 plus sine theta r to be 1 plus sine theta. It is like this. Let me use another color for this one. So what's the region which is bounded by these two graphs? What's the region which is bounded by these two graphs? This is the region. As you see here, the region which is bounded by these two graphs is this one. And theta is going from here to here. Okay, that means, sorry, it's from minus pi over 2 to itself. It's 2 pi. And r is going, look, from the origin. From the origin, it goes to there, there, there. This is the length of r. This r, and this r also. Okay, and here the length of r is 1. So it's from 0 to 1. Sorry, in the above one, the other part is like this also. Here we don't care about it. We just care about the value of r. R is 1. We have that part also there. We have both parts. Yes. I just confused because r, it doesn't care about the axis. It's negative or positive. It's only length. R is the length, is the difference between these two. Is the distance between these 2 points from the origin to the graph. Okay. This is how to find the region. A region was bounded by 2 curves. So now try to find these 2. Try to find the region which is bounded by 1 plus cosine theta and 1 minus 1 minus cosine theta. So okay, do it. Do it by yourselves. Okay, do it. And the beacon. Okay. Look, here we have 1 plus cosine theta and 1 minus cosine theta. To draw these 2 graphs and find the region which is bounded by these 2, let's say r to be this and r to be this. Okay. For the first one, 1 plus cosine theta, its graph is like this. This is 1, and this is 1. Okay, and this is 2. And in the other direction, we have 1 minus cosine theta. At 0 is 0. This is theta to be 0. This theta to be pi over 2. This theta to be pi. This theta to be minus pi over 2. So cosine at 0 is 1. 1 minus 1 is 0. Then cosine at pi over 2 is 0. So you get 1. Cosine at minus pi over 2 is still 1. Then cosine at pi is minus 2. So the region was bounded by these 2 graphs is this one. These 2 parts are the graphs. Yes, that's only finding the region. Then we find the integration. It's easy to find the integration. If we just know what's the region, it's easy to find the integration. It's only the double integration. It's easy. Okay. So here we haven't given any function here. Okay. We will talk about the rule for finding double integration. Then we solve some examples about that. Let's take a break for 10 minutes. Now we have Fubin's theorem on polar rectangles. We say if r to be r and theta, this is our region. R is our region. It is defined by r and theta, where r from A to B and theta is from alpha to beta. Then the double integration of the function of r and theta over the region R equals the integration of f of r theta r dr d theta r dr d theta. Here we have r which is multiplied by the function, then dr d theta, where dr, the limits of r is from a to b. Okay, it's from a to b. Then for d theta, its limits is from alpha to beta. Alpha to beta. This is the rule. Or we can say it equals to d theta dr. We can say d theta dr. So d theta, theta is from alpha to beta, and r is from a to b. Sorry? Yeah? Yes, but here it's, look, even in the previous one, if we are changing the order, it's okay. If both are constants, I mean, if x is from a constant to another constant, and y is from a constant to another constant, it's okay. If you can change it, you can directly change the order without changing the lower and upper limits. But here it's also the same. But for the functions, we cannot do that. We cannot do that. If one of these are functions, we cannot, it's from, let's say, from 0 to cosine x. It doesn't equal to from cosine to 0. They are not equal. You have the Frobenius theorem on any polar region. We say let f of r and theta be a continuous function on R1 and R2. Here we have two regions. We have two regions, R1 and R2. And on these two regions, f of r and theta is a function of r and theta. It's continuous. It is a continuous function on both regions, R1 and R2. We say if R1 to be this region, R is from a function to another one. Here, G is a function of theta. We say R is a function to another function. And theta is from a constant to another constant. R is a function, is from a function to another function. And also theta is from a constant to another one. So here in this case, we must take first the integration with respect to R, and then with respect to the variable, which is from a constant to another constant. We must first take the integration with respect to that variable, which is from a function to another function. That here, R is from G1 of theta to G2 of theta. That means we must take the integration with respect to R, because it's from G1 to G2. And then the second integration with respect to theta, because it's from a constant to another constant. But if R is from a constant to another one, but theta is a function from a function to another function. In this case, we must take the integration with respect to theta first, and then with respect to R. That's all. But here we always multiply it by R. Be careful. Here we have R dr d theta. We have R dr. We always multiply it by the function. Here we have given these three examples. We try to solve these three examples. For the first one, it says evaluate this double integration. We have given a double integration r cosine theta dr d theta. So f of r and theta is cosine theta, and it's multiplied by r dr d theta. So you get r cosine theta dr d theta. Here, r is from 0 to sine theta. Theta is from 0 to pi over 2. From 0 to pi over 2. If we draw the region here, sine theta is this graph. This is the graph, this one. And the area which is bounded by these is from 0 to pi over 2. That means from here to here. For this graph, It's only this region. This is the region that we should find. So the result of this double integration is that region. It's over that region. The double integration is over that region because it says r is from 0 to sine theta. Then theta is from 0 to pi over 2. That's the region. Now, to find this, the double integration, there's no space here. Let me create some spaces, some blank pages here to make it. We now have this double integration. We solve these three examples, as I said. For the first example, we have the double integration from 0 to pi over 2 and from 0 to sine theta. For r, cosine theta, dr d theta. We now find the double integration. First integration with respect to r and the second integration with respect to theta. We say it equals. Let's first take the integration with respect to r. If you take the integration with respect to r, what we get? We get the integration from 0 to pi over 2 for r squared over 2 cosine theta. Cosine theta in this case is a constant because we take the integration with respect to r. D theta. We took the integration with respect to r. And now we put the lower and upper limits for r, which is from 0 to sine theta. Okay. Now we replace r by sine theta, then we replace r by 0. We first replace r by sine theta, then we replace by 0. We get the integration from 0 to pi over 2. For sine theta squared times cosine theta over 2 minus. Then we replace r by 0. If you replace r by 0, you get 0. That's d theta. It equals to a half of integration from 0 to pi over 2 for sine theta squared times cosine theta d theta. Okay. We now find this integration. We have a bracket which is raised to an exponent. We say if we have the integration of, let me use another color for this note. If we have the integration of f of x, let's say f of x to the power n times f prime of x dx, it equals to what? Equals to f of x to n plus 1 dividing by n plus 1 plus. Okay, we just add 1 for the exponent dividing by the new exponent. And here you have the same. We have a sine function which is raised to an exponent. And in the out of the bracket, we have derivative of the sine function, which is cosine. It equals to we say this equals to a half of sine theta to the power 3 over 3 from 0 to pi over 2. We just took the integration. As we have the derivative of the function in the out of the bracket, so you just take the integration. It equals to a half, sorry, 1 over 6. 1 over 6 of sine theta to the power 3 from 0 to pi over 2. We first replace theta by pi over 2, then we replace by 0. If we replace theta by pi over 2, what we get? We get sine of pi over 2 is 1. 1 cubed is 1. We get 1/6 minus 0, which is 1/6. That means this double integration is equal to 1/6. 1 over 6, I mean. It is 1 over 6.
I know it's not this. how we get sine theta squared times cosine theta d theta. Cosine command
Okay, we say every half a bracket which is raised to an exponent. Let's say you have f of x. Every half the derivative of the function, it equals to what? It only equals to the bracket which is raised to n plus 1 divided by n plus 1. We don't write down this one again. It's the same. Okay? Okay. And okay, I'm going to do this, and it takes only 5 minutes. And the last one for tomorrow. In the second example, we have two functions of r equals 1 and r equals 2 sine theta. R equals 1 and r equals 2 sine theta. It says sketch the graph which is enclosed by these two functions. First, we draw the graph. I'm gonna clean this one. Okay. Why? I'm gonna write down the. Just a moment. I'm gonna write down here clearly. It's here. It's the same. It equals to f of, let me use red color. It equals to f of x to the power n plus 1 dividing by n plus 1 plus c. That's, I'm gonna leave it to be there. That's all. The function is, it says we have two functions, r equals 1 and r equals 2 sine theta. And it says find the area which is bounded by these two regions. But first, we are asked to sketch the region. How to sketch the region? We talked about fr to be 1, how it's graph. It's a unit circle. Okay. For r to be 1, you have a circle like this. Is it? This is the graph of r. And the graph of r equals 2 sine theta. R equals 2 sine theta. Let me use blue one. R equals 2 sine theta means it's a circle. Its radius is at 0 and 1. This is the graph of 2 sine theta. And this r equals to this. And r equals to 1 here. It says find the area or find the region which is bounded by these two graphs. So the region which is bounded by these two graphs is this one. We said for sine function, if you have only sine theta, its graph is a circle with radius 1. But with this one here, it's 1. It's 1. But if you multiply it by 2, it gets up to 2. Okay? No. Now, what's the angle? The angle is from 0. Look, it's starting from 0, is it? It's starting from 0 to where? To pi. It's starting from this line to this line. As you see, this region is starting from this line to that line. Okay? That means our angle is from 0 to pi. You say theta equals 0 and theta equals pi. Theta equals 0 and theta equals pi. And also r equals 1. Sorry. From where to where? Look, here we say from which graph goes to the other one. Let me use black one to this one. Already. sorry. Look, it's going from the blue one up to the black one. Okay, from the blue to black, from the blue to black, from the blue to black. Is it? That's it. That means it's from the blue one is 2 sine theta to where? To 1. R equals 2 sine theta and R equals 1. That means the lower limit for R is 2 sine theta and the upper limit is 1. We say the area equals the double integration. Which integration should be first? Here we have function for R. That means R must be first. You say dr d theta. You say R, we always put R for dr d theta. You say dr d theta. You say r dr d theta. Okay. Then the regions from the limits are from 2 sine theta to 1. Then from 0 to pi. We just find this integration. First, we take the integration with respect to r. We get a equals the integration from 0 to pi for r squared over 2 from 2 sine theta to 1. Okay. This is d theta. It equals to the integration from 0 to pi for 1 over 2 minus 2 sine theta squared over 2, which is 2 sine squared of theta. Is it? Here you have 2 sine theta squared over 2. If we give the square for 2 and the sine function, we get 4 over 2. We get 2. Okay? This is d theta. Now we say sine squared of theta. We use this rule, this identity of the trigonometric functions. We say sine squared of theta equals a half plus minus a half of cosine 2 theta. Okay, let me check if I'm correct. It's if this cosine 2 theta or sine cosine half of theta. We say sine square 2 of x equals 2x. That's it. Let's use this to check the rule. I think you are correct. That's it. Yes, for cosine squared of x is 1 plus cosine 2x over 2, but for sine it's 1 minus cosine 2x over 2. It's 1 minus half of cosine 2x, 2 theta. Now we replace this by that to find its integration. We cannot find sine squared of theta its integration directly because we have it's sine squared. We have no derivative of sine. That's why we say a equals the integration of from 0 to pi for a half minus 2 times 1 a half minus a half of cosine 2 theta d theta equals to, we multiply this 2 into the bracket, these 2 I cancel out with that, and we get the integration from 0 to pi a half minus 1 plus cosine 2 theta. We get that. So these 2 are cancelled out. That's 1 times cosine. Okay, so it's d theta. Now we say a equals from 0 to pi for minus a half. Here we have a half minus 1 is minus a half plus cosine 2 theta d theta. It equals to, now you can find its integration. It's easy to find. As minus a half of theta, as we take the integration with theta, so the integration of constant is constant times theta plus integration of cosine is sine, but we must have derivative of the angle. The derivative of the angle is 2, so you see it's a half of sine 2 theta from 0 to pi. If we first replace it by pi, we get minus a half of pi plus 0, because sine of pi, sine of 2 pi is 0, minus minus a half times 0 plus 0. So that's 0, and we get minus pi over 2. And here we got a negative value, but area, it must always be positive. Okay, so we just take the absolute value for the result. That means A equals the absolute value of negative pi over 2, which is pi over 2. That means the area is pi over 2 units squared. That's the region which is bounded by those two R functions. But in the question, it's given that theta equals to 0. It means that one not given. You should find the angles. And it also may given that theta equals pi. That means find the region which is bounded by those two curves from 0 to pi. لو أنا مقشان هالنيات